Today I want to show you the controls for the full-size remote control Chevy Silverado we're building and how I set them up. This one's for the steering wheel and this one's for the gas pedal. Here's a small clip of the truck we're going to be using. The problem we had setting up the controls is that the stepper motor and the servos take a different signal than what the remote control car controller gives. So I had to use an Arduino to convert the signal from the controller to be the right signal for these. An Arduino is a tiny computer board that you can program to do all kinds of cool electronics things. You need to know C or C++, but I learned it on YouTube, and people are making all kinds of really cool projects online with these. I put a link in the description of this video for each of these items, so you can check out the exact items we're using for our project if you want to check it out. For example, the signal from the remote control, which is this yellow pulse, is just a pulse width between 1 millisecond wide and 2 milliseconds wide. And I'm having the Arduino convert it to all of these pulses that the stepper motor needs to control it. So the servos have their own power supply, 16 to 24 volts, and then a signal in from the Arduino to make them go to the right angle. It's also got motor mode where you can control the speed and have it keep rotating, or you can put it in servo mode and just have it go angle. And the first servo I bought had two potentiometers here. One was to control how far it moved, and one was to control the center point. But this one only has one potentiometer. I ordered them both a few weeks apart, so that's interesting. I'm just using them for the angle and servo functions for the gas pedal and the brake pedal. The servo code was pretty easy. I just used this servo.h library from Arduino, and it does all the code for you. They just give you a few little words you type in to make it what you need. I named my servos throttle servo and brake servo, and then you attach the servos to a pin on the Arduino, and then you just write how many microseconds you want the pulse width to be, or you can write angle also. So it's pretty simple. I'm configuring the stepper motor to do what I need it to do for micro stepping and current and stuff. It's a UIM 8696 PM. I also, to program this stepper motor, I had to get this USB to UART adapter, and it wouldn't connect to my computer at first. I had to download the USB to UART driver from Silicon Labs online, and then I got it working. At first I had the transmit and receive wires mixed up, and after I fixed that I was able to use everything. But here's the program that comes installed with the motor and whatnot. You just connect it, make sure it's on the right COM port for your USB, and then click open, and then you click get, and it'll come up with the serial number and other information. And this has the information that's already on the motor. I already have it set up for half stepping, so the micro stepping divided by 2, and maximum amps I put as 6 for now. And then you just press set when you're done. And by the way, the motor has to be powered from a main power supply while you do this. And then it says to cycle the motor, so you just turn off the power supply and turn it back on, and should be all set. And then close it, you're good to go. So the stepper motor was much harder to program. I tried some stepper motor libraries and I didn't like them because they had jitter and missed steps and everything, so the motor just didn't run smooth. So I wrote my own code. I don't have time to explain everything here, but I do have everything commented with double slashes and gray letters so you can see what the code does. I will show you that I had to use the data sheet from the chip on the Arduino, which is a very big data sheet. I'll show you that in just a second. and it'll show you everything you can do on the Arduino. So here's the code. I'll start at the top. Scroll through this. I don't know if you can see it. Good luck. Interrupts. Like I said, I learned C and C++ on YouTube. So it takes a while, maybe a few months to get okay at it. You can use ChatGPT or Grok or any AI to help you code because it's pretty good. Just don't go exactly by it. You still have to write your own code. But yeah, I used the B timers to generate a very steady pulse for the stepper motor so that no jitters. So here's the chip that's on the Arduino Nano Every, and it's got hundreds of pages of things that it can do. I'm not showing a good job scrolling through it all, but it describes how you use every single thing on the entire chip. It's kind of complex, but if you want to have fun doing anything you want, this is it. So good luck.